presentation. Our first presenter, if you will be Daniel. He's got a turtle application there. So let's see if I can do this. Now, how do I
think I can grab the screen sharing.
I make the co-host, and then I think you can share the screen. Yes.
Can you see my screen?
Yes.
Great. So
can everyone see his screen? It's just me.
No, I can see it.
Looks great.
Great. So as I mentioned on the Slack, I pretty much just followed what was in the book. Like, this is not really meaningfully very different from the bear classifier. It's just that it's with turtles and it's 4 categories instead of 3. So I tried to pick a few somewhat interesting examples to look at, just to think about the different ways where it works well and where it fails. I did not pick these, or I didn't ensure that these were not in the training data. So some of them that do well could conceivably have been in the training data, but I used a different search engine and different search terms. So hopefully it's different. So the first one I'll look at, this box turtle. I thought this one was a little bit different because, as you can see, it has no background, which was different from all of the pictures that I saw in the training sample, at least. So we'll go ahead and upload this one. Click on the classify button. Box turtle, very high probability. Pretty good at that. The next one, Howard the tortoise here, I can be sure that this one was not part of the training sample because I took that picture, and I don't think that Howard the tortoise is an internet celebrity, but you never know. So grab that one. Classify. Really, really confident, no doubt that's a tortoise. Works pretty well. So I didn't do anything to try to address the sort of other category which we had discussed last week, but I still think it's an interesting question. So I took a picture of my cat, and if we run this through the classifier, it's pretty sure it's a soft-shell turtle. I guess one way to think about it is the model is assuming from the very beginning that it's going to see one of these 4 types of turtles / tortoise. And it's thinking, like, given that this is a picture of one of these 4 types of things, which one is it? Then it thinks it's a soft shell. Though interestingly, if we look at this kind of not so great picture of a soft shell, it's mostly underwater. You just sort of see the snout. If we upload that one, it gets it right, but it's not very confident that it's a soft shell. It's 46%. So I thought that was kind of interesting fringe case. Whereas if we look at a sort of different one here, this one is mostly buried under the sand. Hit classify on that. Very confident that it's a soft shell. And I think it's probably because one of the defining features is that kind of long snout that they have.
Exactly.
And you can't see that in the face forward picture. All of the others that I looked at here were predictably pretty accurate. So I won't go through all the rest of these. But I thought it was, again, pretty interesting that you had this one sort of outlier case where it got it correct, but wasn't very confident. It was actually more confident that if this were a turtle, it would be a soft shell turtle, my cat. Yeah. Any questions I can go over on this? Like I said, it's pretty much the same implementation as the book. But the only thing I did differently was I made it so that the upload counter would reset to 0 every time because it was bugging me that kept accumulating.
Oh, yeah.
Cool.
Did you look at trying to get rid of the upload button altogether and have the classify as one function?
I didn't.
Yeah, I wanted to look at that, and I ran out of time cleaning my data set.
Yeah, just make like upload and classify one step.
Yeah, like he does in the video.
Yeah, that makes sense.
One thing you could try as far as that other category is just to do a multi-category classifier instead of a single. In other words, have a classifier that can do multi-label, that can output like more than one thing if it finds it.
Yeah, that makes sense.
And that might work better as far as none of the above as well.
Mm-hmm.
And then it would also be able to detect if there's two different kinds, say, or three, it would be able to detect that as well.
Yeah, that's one thing I didn't pull up in my examples, but it actually did a pretty good job in general if you had pictures of like 3 of the same type of turtle, which I guess makes sense
Well, if you
given,
did multi-label, then it would possibly be able to recognize if there's two different kinds, you know, what they are. So that might be worth a try.
Yeah, and there's
definitely
an example of that in the beginner's vision tutorial.
Oh, cool. Good to know.
I think it's the third one down. It's like cats and dogs, animal breeds, and then multi-label.
How many, what do you call this? How many samples did you have for each category?
So just following the book, I did 150 for each. And then after filtering some out, I think it was still more than 100 examples per.
Which transformation did you choose?
What was it called? The one that does the randomized cropping and augmenting and all of that. Yeah.
It'd be an interesting experiment to try, see how many you actually need, like try it with 50 or 20 and see how it does.
Definitely. It's kind of a question of how far the pre-trained model can get on its own, or with just a little nudge in the right direction, I guess. Actually, like, can you tell the pre-trained models that you're only interested in a certain kind of classification without, I mean, I guess it would have to be things that it was trained on already, but given a pre-trained model, if it already has 2 types of turtles in it, can you say that you're only interested in this kind of classification and not all of the other stuff? And would you ever want to?
I don't follow that. I mean, the pre-trained
so given
model
like that
is
this
usually
is
on ImageNet.
Yeah. But instead of having it set up to where if you give it an image, it's going to give you the top 10 things that it finds in the image, would there be a way just to use that for classifying between 2 types of turtles that it already knows about without all of the other stuff? I don't think that there's any reason you'd want to, but
I think you just do the same thing. You'd edit the head.
Right.
Yeah.
You don't
only include those 2 categories.
Yeah, you don't normally get the labels from ImageNet anyway, right? We're not using those labels at all. Matter of fact, where are those? They're gone, right?
Right. That's good point.
You just get the.
Are you saying if you trained something to like recognize 10 kinds of turtles and then you only wanted to recognize 2? Is that what you mean?
I guess I was just trying to think about what the very, very minimal approach would be to, and as far as like a number of training examples for using a pre-trained model in this way. So in this case, I used 150. Just thinking about how minimal it could be, but I think that would just require some testing.
Yeah, it would be kind of interesting, I guess.
And it also depends on how, like during the demo or the lectures, he mentioned like the real pictures are going to be really grainy and at night and things like that. So your minimal
underwater.
Yeah, your minimal training set would be the pristine data set, but it would be limited by the fact that they're pristine.
Right, but then you'd use augmentation transforms to adjust the contrast and the balance and the brightness and everything else to skew it and make it weird. Yeah. So 150, if you have 8 transformations being done, it's 150 times those 8 transformations.
Right. All right. Well, thanks for looking. I will stop sharing now and can look at the next one.
That's cool. Very good, Daniel.
Nadia, are you ready to?
I actually can't show you anything because I had to go back on my Windows machine.
Oh.
So
Okay.
I explained to some of you that the only way I got it to work in Binder is on my Mac, but I tried connecting Zoom on my old Mac. It didn't work, so my connection is not stable. So I wonder, like, if I send you a link, can somebody try it? Like, would
I tried your link earlier that I don't know if you sent it in the middle of the night or whatever. It was there when I woke up this morning.
yeah.
And it gave me an error. It was a
Yeah.
404.
Well, and that's something I noticed. The link doesn't stay long, right?
Right.
Yeah, so like I can go get the link right now and see if that works.
That's a good question. So the Binder thing, it builds and then it launches and then it stays alive for a while. But I know if you go back, it doesn't, it 404s, but shouldn't it rebuild and relaunch?
But it doesn't. That's what I would think.
Yeah.
Service, like a REST API would stay up, right?
Well, yeah, but it has to recover and go away and save money for the guy, but it should rebuild, I would think. I have one.
I think I got this same issue on the forum post that I did. And then somebody went and said, you shouldn't be using that link. You should.
Right.
Blah. So I think that's the reason. So it will launch, but you can't use that link that you first get.
Yes, there's a more generic link. That's a good point. If it has a token in it, it'll only last a short while.
Yeah. But if Anya can fire up the token, we can look at it in 5 minutes or something.
Or even the non-token version.
Yeah.
Should build.
I don't think I did any tokens.
Well, they gave you a URL when you clicked in the Binder thing. It gives you a URL.
Yeah.
That's the one you should use, not the one that renders when you launch that. Because the one that renders is the live one that's only going to be active for 5 or 10 minutes if you leave it idle.
Okay, so let me see if I can get my link. Let me log in and get it.
Yeah, this is good practice. The Binder thing really threw me for a loop. Andy, I appreciate all the work you did on yours, because look, while you're doing that, Anya, let me tell you what I had to do. I was kind of taken aside by all the Docker talk, so I was very convinced I was going to be able to build my own little world in my Docker container and have it do everything. Really hard. Too many steps, too many environments. And then I thought I could just take my export pickle file and use it on just some generic thing I stood up. Way wrong. The export pickle file has to conform to all the pieces that were there when it was built. So I went down a really weird path. I did finally take yours, Andy. I took your repo, precise repo, and used it as was, put my pickle file in, and renamed my classifier, and it ran. Because my pickle file had all the stuff that you had in yours, the builder, the learner.
Yeah.
So things are complicated under the covers.
Yeah. That's what I was finding out, and that's why I was telling Anya that you can't like jump from Linux to Windows, from Windows to Docker, it has to be kind of the same environment.
I got it. So I learned this week, I only have like 5 or 6 hours per week.
Exactly.
In my budget. And if I'm going to keep it to machine learning, I've got to put my blinders on and do machine learning only.
That's what I did. I finished lecture 3, the video, and then I came back to Binder. So I sent a link in the chat. If anybody can click and see if it works. I'm classifying skaters. I'm gonna check on my Mac if it works on my Mac.
There we go.
Do I share
but you have to find a picture of either figure skater, skateboarder, or
a cat. Or a cat.
Speed ski.
Who wants to drive? I can put somebody to drive here. Who's the quiet one?
I would drive, but it will not work.
Ray, do you want to drive? Click on the link.
Let's see if I can do this. I'm on an iPad, so that might be a challenge. And
your screen.
Let's see here.
I wonder if it works at all at this point. I know it was working at 1 a.m. last night.
It looks like it's trying.
Do you get a upload file? So I only have one button. I implemented it with one button where you upload a file, and you would need to provide a picture with Skater.
Yeah.
I've got it up and running if you want me to take it on.
Okay.
I wish I could feed you a bunch of skaters pictures.
Do we see my screen again?
Yeah, so this is a skateboarder. Yes.
Yep. This turtle is a skateboarder. So I guess let's look
probability.
up figure skater. And then do you have any preference of a picture that I should look at?
So my favorite is the second one.
This one?
Yeah.
All right, let's.
Her name is Alexandra Trusova.
Save image as. Skater.
Here we go.
Very good, very good.
Yeah, so the result is understandable with the turtle because I only trained it on skaters, so it tries to put it in any possible category, and the turtle is not as graceful as ice skaters, so I guess it goes into skateboarder category.
I always want to know how my cat's going to be classified, and he is very graceful.
Then you should Google skateboarder cat. Yeah, try that. Any of those, because, you know. Because I tried multiple animals on skateboards.
Wow.
Here we go. And I tried Snoopy because Snoopy is, you know, often shown on skates. So Snoopy on skates sometimes came returned as a skateboarder.
Should try this one?
Yeah, try that one. I tried a bunch.
Yeah, I assume the skateboarders, it's going for the wheels. They all have wheels.
Yeah.
How many?
I'm impressed at it, yeah.
How many?
But try the fourth picture where it's on ice skates.
But it's a drawing. I don't think that's...
How many images did you train on?
So I went with the default 150.
Didn't get that one.
Yeah, it mispredicts because, yeah, you're right. It's a drawing.
Mm-hmm.
I went with the default. I wasn't really focusing on, I was focusing on the code more than making it a, you know, 100% fit to validation set. I still don't understand how when we do data augmentation, it's supposed to increase the data size, right? But like, I couldn't see how many images actually went into the model as an input. Does anybody know how to look that up?
Well, it would end up in the folder.
Well, no, she's saying if you add augmentation, how many separate rotations and color changes and hues and things happen? If you go with the default, I think if you do the shift tab, it'll show you all the ones that are default settings. So it would be whatever your image number is times those number of transforms. But if you go in like I had to do and change some of the defaults, you'll get a different number.
But it's sort of strange the way you know, you're doing like data equals, and it's you're always using data equals, but they're all stacked in there, right? Like you don't just, they're additive.
In the same image, or does it make new files?
I gotta look at a notebook.
I don't think it saves new files. I think it just transforms them and then processes them as if
it makes the data loader. It somehow makes new objects, but it doesn't write them to disk.
I'm guessing.
Yeah, that's right.
Every epoch, if it's a random, every epoch it will do a different transformation on that image.
Oh. Yeah, in fact, I think the new version of Fast.ai does the transforms with the GPU, at least the batch transforms.
Yeah, the batch does.
That's like to make it even faster.
Sure.
So do we have visibility to how many images actually were evaluated during training?
Good question.
Well, I mean, I think it evaluates one for each image in the training set, but they're going to be randomly transformed.
So doesn't it indicate that there is data augmentation occurring too, which would mean multiple per?
That's what I would expect.
Yeah, I think it's one per image in the training set, but the image, each image is randomly transformed.
Yeah, there's like 10 to 12 default transformations that are done. And if you just go into the AUG_TFMS, like parentheses, and go in the middle of that and do Shift Tab, it'll pull up what all the defaults are.
Okay.
In your notebook. And there's like maybe as low as 8, maybe as many as 12 that are just the standard ones. But you could turn them all off or turn them all to different settings. You can make it rotate. The default's like 10 degrees of rotation, but you could make it, 4 degrees or 15 degrees if you wanted.
Mm-hmm.
Yeah, but if you look at the number of images that it actually runs through in an epoch, I think it's the same as the number in the training set. Like if you just divide the size of the training set by the batch size, that's how many steps it's going to do.
Yeah, I agree with that. Because it's not making new files.
So I just have one question. Like when you go through like the second notebook, it says, it seems like you're reassigning. You're like bears equals bears.new squish. Is it adding, like, is it going to do squish, or does it just do the last one where you've reassigned it?
I think that's just showing you the different things you can do.
Okay, but when you run the training, then if you do each one, you're only working on the last one. It's not like you're working on all these different.
I think that's correct.
Okay. Thank you.
All right, thank you for showing my work.
Yeah, no problem.
Thank you, Daniel.
One question that I had, so given that the models expect all of the training data to be of the same dimensions, and we go through all of the things to accomplish that, what happens when you pass it a picture to predict on that is of a totally different size? Is that cropped in a certain way, or I guess I didn't see in the code what was happening there. So if I'm training it on like perfectly square images and I pass a more vertical one taken on a phone or something,
short answer,
what's happening there?
Short answer is there's something called center cropping. So it takes the image, if it's not square, it's gonna take the centermost part. I mean, size it, like get the, what do you call that? The lowest dimension. So if it's 200 by 200, so it's gonna, let's say 200 by 300, it's gonna take up 200 by 200 of the middle part of the image. And it does this to the validation set. So the augmentations don't apply to the validation set. So the augmentations stay the same across like epochs. So that's why you can compare the metrics. So if you're improving, it's doing the same thing again and again on the validation. But as everyone said already, on the training set, it varies it every epoch. So yeah, so basically there's two sets of transformations, one for the training set and the other one is for the validation set. So it's just the center crop.
Okay, so by default, at least it's the center crop. So if I had a picture that had a turtle at the bottom and it was a tall vertical picture, it probably would just get a picture of the landscape.
Yep, exactly.
Okay. Thank you.
Okay, I guess we'll do Arcade. Do you have your thing ready? Let me make you co-host.
Right. Let's see. Let's see. Do you see my screen?
Yeah.
Okay.
Let's
see. Let me move you guys off to the side over here. So I ran into a couple things. I was trying to have a homework project that'll help me with a work project. We had a guy that was basically heading vehicle identification project at work, and he quit to go work at General Dynamics instead, because obviously the military industry is a more stable environment with perpetual war than racing industry. So a guy took it over who is a really great programmer, but has never done any deep learning at all, and he's not getting very good results. And every time he retrains his model, it's not coming. It's not doing better. It's actually sometimes getting worse. So what I wanted to do, if you see this car here, we have these photographers that take these pictures. So I wanted to look at a little bit different approach to how to identify cars. And the main thing is we want to know which specific car it is. So by what car number. And you can see, like in this picture, that you can't, like I can see this number because it's really big on my screen and I know what car it is, but you can't really see the roof number. You can't really see the door number, but you see this really tiny number here under the headlight. And so they were doing some things to try to find these numbers, and it's not really working. So I took a little bit different approach. We have about 40 cars in the field every event, and 40 classes is a lot. So you need a lot of data to study that. And the problem with this is, like, paint schemes change all the time. The sponsors change every week. There's a lot of unknowns that go into like what the car looks like from a week to week basis. So they tried to focus on just the number, and it's kind of, I mean, they're doing okay, but they're still misclassifying over 200 images a week, and not able to get it any better than that. So I took a little bit different approach, and I said, well, what if you did it as like a cascading search? Because we know that the car numbers are also associated with the manufacturer, and the manufacturers have these mandated, you know, Mustang with the big horse on the front. They have their particular grill. And so my approach is to start with dividing them into the 3 manufacturers and a junk pile, which I can talk about in a minute. And then from there, you know what car numbers would be in. So you're kind of narrowing it down. So instead of having 40 cars, there's only like 6 Toyota teams, and there's like 12 Chevy teams, you know. So you start getting these smaller, it turns the classification problem into a simpler problem. So this is just my theory. I don't know if this is gonna work, but the results that I got on the manufacturer were 100% accurate. So what I did was I took 2016 high resolution images that were from about 4,000 something pixels wide to 6,000 pixels wide. So there's a varying sizes. The backup cameras aren't as high resolution. So when their battery the photographer's battery dies, he changes randomly through the event to a different camera that has a different resolution. So I had to write this script on the left to adapt and fix all my images. Well, first of all, I just tried to upload everything to Paperspace, and then I found out that there's a 5 gigabyte limit to the storage for the free tier. So then I had to reduce the image size because I was going to reduce it anyway, but that burned up about 3 hours of my life just trying to upload it and then find out that it won't upload because it's too much. So I came over here and wrote a quick script. It's pretty simple. And I'm going to post all this stuff so you guys can see it. But I'm basically telling it here that I want my width to be 684 pixels.
Hey, RK, can you increase the font a little bit? Control plus.
Let's see. Honestly, I don't even know how to increase the font size. Does anybody know off the top of their head?
Control plus, I think.
Do I have to highlight it?
No, I don't think so.
Control or command? Command.
Oh.
I'm on a Mac. Sorry. Is that better?
A little bit, yeah.
Here, I can do some more. So this is obviously just building all my paths into a list so I can loop through it. And then I'm specifying the resize. And then I come in here. My function is basically walking through this path list of these directories. And it gets the resize width and the resize height is based to maintain aspect ratio. So I didn't want to squish or stretch anything. And because these are all much more higher resolution than 684, you're
yeah, won't lose anything.
Yeah. So that took me a little time to figure out how to do. And then so when I actually got the pictures loaded, these are the kind of pictures that I'm looking at. And so you can see like some of them have 2 cars in it, and I'm more interested in this center car. So I haven't really done anything to address that, but I noticed it. Sometimes the cars are really close. And then my augmentations, can you read this okay?
Yeah, pretty good.
So the do flip is a standard transformation augmentation that is part of the default. So I have to set this to false. In NASCAR, most tracks, we only go one way around the track. And so when you flip the image, it actually looks like you're going backwards around the track, which I didn't feel was applicable. So I changed that to not have that flip it. And then I increased the zoom from 1.1 to 1.2 just because some of the cars are really small in the image. And then you can see that I ended up training for 5 epochs instead of 4. And it was weird because I ran it a few times. And on this 4th epoch, I had error. But if I did the 5th one, the 4th one had no error. So I'm not sure exactly what was going on there. But you can see my confusion matrix has 0 misses. So looking at my top losses, even though I had 0 misses, you can see where it's not as confident of certain things. And some of these, my assumption was if the car was partially, you can see this is maybe you can see.
Fence.
If like these are infield lights, for night races. And if the car was partly obscured by that, I would put that in my junk set because I didn't want it trying to learn that as part of the car. But you can see if the front of the car is visible, it actually gets it all right. And it's not too bad. I mean, even like, this one's 19%, 25%, 73 versus 31. So I I probably should move any ones that aren't completely obscured.
Actually, I think that's that, like that one on the left is saying it's a 73% probability of being junk.
Yeah, and it is junk.
Yeah, so it's not, it's the 31 is the loss function, but
okay
3 is the probability.
Yeah, okay, that makes sense. So I was pretty happy with those results. And then, so what I did was I had my 2,000 pictures, and before I submitted it to all this, I removed a random 70 pictures to be a test set that the model in training would never see, like Jeremy talked about. So I have, it's around 1,600 training images, and then 400 and something test or validation images, and then 70 test images. So what I was doing over here, and you can see this is pretty much just a rehash of what the app was in the workspace, but I can upload. So if I upload this, which is clearly not anything, I get the junk probability very high. And if I upload something that should be really easy for it to get, like a very close photo, that it's a Ford, right? Because these are the distinctive characteristics of the Ford.
Maybe. Obviously, but like, are all the Chevrolets, do they have like, they kind of have a look to them, don't they? Like cars have looks to them.
Yeah, for sure.
Manufacturer cars, yeah, that's awesome.
Yeah, similar to the dog breeds, right? So one dog might have a different color ear, but the rest of the features are very Great Pyrenees.
Uh-huh.
So if I pick something further away, and it's extremely confident. Now, these were never seen in the training or validation set by the model.
Right.
So these have been isolated completely. And you can see the Chevy bow tie.
Mm-hmm. Mm-hmm.
So then the next step is to isolate the pictures in another step and do actual car numbers. Because you can see, like, there is a 3 right here. It's just tiny. And that's a 3, but how would you know that was a 3 unless you were a human? So it's like a whole nother level of difficulty to, like I'm saying, to go just to what actual team it is, as opposed to dividing out a manufacturing stuff. So hopefully I'll have an update for you on that next week. Did anybody have any questions about this?
I think it's interesting, like the junk thing, because like the junk just means it's like obscured. So you've like trained it to identify pictures that are like obscured, right? Like,
right. And let me see, I can pull up. Well, okay. So occasionally the photographer will forget to take his lens cover off, right?
I've done that.
Right. And so I don't, and this is what, like that image, like what exactly was going on when he took that picture? I don't know, but I need to do something with it. So like what Daniel was showing where his cat was a turtle, like I was trying to mitigate that by saying anything that doesn't make sense should be like this, where the foreground image are these safety trucks. And this thing is completely, now this is the super high resolution picture, obviously, but like there's all kinds of stuff that's going on that, like, I don't really care to see what the car is doing right there anyway, just from an engineering standpoint. And then sometimes you can see, like here, this car happens to be in between the lights, but you could imagine if it was right here that a lot of the car would be obscured. So I was just trying to be extra safe in that and saying, like that. Like if it misses on that, I don't want to punish the model, because in some ways I don't expect it should like get that right, if that makes sense. So I think you could change it from, junk. I called it junk because, I live in North Carolina, so we talk about junk a lot. But you could call it not worth classifying.
Move on.
As a class, right? Like, I don't care about seeing this picture. I can't get any useful information out of this picture. It's too obscure. So that's what that was.
Except for that big old 15 on it.
Oh, you got the 15, but do you, okay, so it's one thing when you're seeing it in the high resolution mode.
Yeah.
It's another thing when you're categorizing it like that. And so I was probably being too careful. I mean, honestly, and like because my coworkers are having so much difficulty with this project, I was trying to be like really isolated and like make sure I could get a good model first. And then you start throwing these things in that are like way off the, zoomed out and partially obscured, and see if it still recognizes it.
So are you saying it was able to recognize the junk images automatically?
Yes.
That's very cool. Yeah.
Let's see, where'd my... Yeah,
Did you run into cases where you disagreed with the classification? Like, were there some that were classified as junk that you thought, like, that's kind of a clear enough picture?
Yeah, I mean, from like what we were just looking at, me randomly pulling up stuff out of that out of that test set that the model never saw, there are definitely, like Dave pointed out, there's clearly the 15 in between those lights, and I was being maybe too cautious and saying, well, let me throw those out that are like way off in the distance and zoomed in, because I didn't want to run into problems where I'm like stuck at 80% and can't get better. So that's where I just said, well, let me make this new junk category, and anything that I don't expect it to be a useful picture anyway, I'll just throw in there. So that's how I built it, is I went through 2,000 pictures and said, this one's junk, this one's not, this one's junk, right. This one's not.
That's your domain. You are choosing to have the lights not in your domain.
Correct.
Okay, great.
Yeah, and I'm not saying that's the right way to do it. I just felt like I would get better baseline results doing it that way, and then I can always move forward with my next 6 hours of progress next week, right?
Exactly.
So did you also go through and remove pictures that you thought were too similar?
I did not, because the progression around the track is actually, they are very similar. So if I just go to,
what is similar? What does that mean?
Like,
so they're basically time series pictures.
Oh,
right?
Oh, the same car, just a little different in the frame.
Right. And so let me see if I can get...
Wouldn't that reinforce it somehow? I don't know.
Yeah, I was thinking it's sort of the data augmentation just by virtue of the sample.
Yeah.
So if you look at like this series of pictures, like the car is literally coming around the track, and these guys are just sitting there with their finger on the trigger.
Yeah. If there was some kind of a constraint where there was a high cost to doing something with X number of images, you might have to whittle them out, but maybe it can't hurt, right? It wouldn't hurt. It would only cost you more.
So if you have several pictures of the same car, they cannot go into both training and test sets. That's data leakage right there.
Good observation. That would be wrong.
So if you're preparing your data, you want to make sure you split them by day maybe. So the same car, like this car of this color, only goes into like either training or validation.
Huh. Interesting. You only have 40 unique cars in the whole batch of thousands of pictures?
Correct. Yes, about 2,000 pictures. I mean, it's trained on 1,600.
40 unique cars.
But yeah,
it's like cats and dogs. Yeah, got it.
Right. So yeah, like there were 37 breeds or something in the.
But usually the cats aren't all the same cat. They're actually different cats, but they're just still cats.
Right, but they're different views of the same car.
Right, but it's still the same car, right? The same paint, or is it actually the painting changing week to week as well?
No. Well, the paint does change week to week, and this was trained over data from 3 different events.
Okay, but yet the same number, which you'll get to soon. That's an interesting, very interesting problem.
Yeah,
and good observation, Yuri, on the training and the validation set. That's a nuance that I don't know if you thought about. Maybe that's why it's doing so well, but who cares? It works. Right?
Well, yeah. And you can see how far behind my thing is trying to run. It's like still running itself.
Oh, yeah. Thanks.
Yeah, but I think the point there, they raised a good point, which is that do the cars stay the same? I mean, do some cars stay the same from week to week, or there's like a natural tendency? Because the one thing is you build a model and then you try to use it in like, okay, the next week I'm gonna have a new set of pictures, and these are the cars that it hasn't seen before. So in that sense, it might be, yeah, different views, but you don't train. I mean, you should try to simulate it in such a way that it does mirror how you will use it in production. So I think that's a good point that they raised, that your model might be good just because the way it's split it between the validation and the training set is that the same car is going to be on both the training and the validation set. But if you're going to use it in production, obviously it's not going to see the same set of cars. So in terms of just recognizing the manufacturers, what would be a good exercise would be, what if I simulated that? I took a bunch of pictures from, let's say, the last 3 events, and then my validation set would be a set of cars for the next event after that, and see how well it really does. And you can use a test set of something after that as well. So you basically can simulate that how you would build a production would be something that you would encounter. How you build your model is the way you would use it, in that you can like train it on a label the first, let's say, 4 events, and then the next event will be your validation set, and that might be a better gauge of how it will perform in production, which is actually one of the things that they teach, they focus on. Because I have a couple of, I don't know if it was here or some other forum, but that was like how to get a good validation set is one of the, Rachel Thomas has one of the Stu articles on those, how to build good validation sets, which is pretty good. So yeah, so you might use that.
In that case,
the other thing, I'm gonna try to look for that. I don't know if I can find it in time, but I'm gonna definitely use that.
You're segmenting.
How to find good.
Segmenting your training and test via, in this case, time, to guarantee a separation.
Yep.
Well, what I'm saying, yeah, but if you can still see my screen, like this is how drastically the paint scheme changes.
Yep.
That's the same car from 1 week to the next.
Yep, exactly.
So
that's why you should try to simulate that. So one car might be your training set, and then the next set, same car in the validation set, because that's
you're saying to isolate by manufacturer.
No. Change it by how you would use it in production. So the way you would probably use it is, okay, I go hand label all of these things, like my data for the last 5 events, and then, but I would then build my model, and then I would go and, is that how you plan to use it? Or I'm kind of assuming that that's how you would use it, but maybe I'm wrong. Well, or do you like, I have 1,000 labels across all 10 events, and then I'll label some of the one for each event, and then classify the rest? Is that how you would use it? I guess it depends on how you would use it.
Yeah, I think you're hitting on what makes this such an ugly problem, is because when this car is on track, there's no information about this car, right? And then the week after that, it's this car.
Yep.
And then the week after that, it's this car. And then the week after that, it's this car.
So I think that there's an approach that might actually be a lot better than deep learning for this. If you did like a semi-supervised learning, where it's you apply a clustering algorithm, and then you would go through and label like the clearest, most central examples. So if there are 40 cars in a race or something, you maybe would only have to label 40 things. And then because the images are so similar, it would automatically label all of the rest of them. So if you look into semi-unsupervised learning, that might be a better approach.
Can everyone mute that's not talking? There's like an echo.
Yeah, I agree with Daniel. I think this doesn't fall into classification problem. This could be object recognition, not object classification, or clustering, or some other algorithm. Maybe a sequence of different algorithms, just to give you an idea. Because classifiers are very limited.
Well, and it gets even harder when you have multiple cars in the same picture, right?
And that's where you do object recognition and then object location, and then only then, once you located your object. So if you have 3 cars in one picture, you locate each car and then you classify each car. So if you have like a banana, apple, and an orange, you would have to bound box each object and then classify each object. But that's beyond classification.
Yeah, and that's the approach that my coworkers were trying and having very little success with.
Yeah, it's a cascading problem. But since you guys are trying, you'll find a solution.
I'm not convinced that you're not on the right path by making the problem very small. Really, you're going to be doing some kind of a classifier of a number appearing on only a few number of models, right? At some point, you hope to get it down to just Chevrolets, and there's only 7 of them. And as long as I can determine which one of those 7, which will start to ignore color, but it will start to look for numbers.
Yeah, and that's what I was looking for.
It might work. That's really a good approach.
I saw the way they've done the bounding box, and part of the problem with the bounding box is if you do your image resize prior to doing your bounding box, then when there's one car way off in the distance, you're ending up with this really tiny, like 120 by 120 pixel image. And then because your smallest image is 120 by 120, everything else has to be 120 by 120, right? Because they all have to go through the CNN at the same size.
Yes, that's true. But can't they resize?
Would enlarge it, right?
it'll automatically size it without loss of information. That's a technique also.
Well, you would have to do super resolution.
Well, no, you'd still retain the information. Well, maybe not. But
I think sometimes it just works. Like last year, I did the first 2 classes, and I did like a Prius classifier of different generations of Prius, and it was just like dealership photos, and it did the interiors. I mean, it worked really well, just from pictures you wouldn't think it could identify it from.
Well, all right, this is pretty much all I got. I don't want to burn up all our time. Thanks for everybody's input. I appreciate it.
Yeah, thanks for sharing. Really interesting problem.
Yeah.
One last thing, advice. There's a chapter in the book that unfortunately wasn't covered in the lectures. It's chapter 7. It's called Resizing and TTA, where basically the focus is on how to improve the accuracy of a model. And that might be of help. So it's not covered. So if we're focused on the video lectures, we probably won't cover it. But I suggest go read that, because there's a couple of techniques. I don't know if you're familiar with it already. Something called progressive resizing, where you start out with a small model, train quickly, resize it, take the same set of images, put in something larger, and then train it. So you can train pretty quickly by starting out with the small sized images rather than trying to train big images. And then over time, like 3 or 4 times, I think, you start using, because you have high resolution images, right? But they're slow to train. So, but if you start out with small images, they train quickly. So there's like techniques that you can probably use there in that chapter, which is never covered, which was never covered in the.
And like I showed before, I'm reducing.
I'm gonna.
Okay, sorry. Space doesn't work if you're actually clicked into a Jupyter cell for unmuting yourself. But yeah, I'm already reducing the size of the image before I train it down to 684. Where's my 684 by 456 is what I'm reducing it to before training. And you can see it only took 5 minutes to train. I don't think the training time is a big deal. And then obviously, as you get more data and everything, training on bigger images, I think will provide better accuracy. But it's kind of a toy project at this point, so I was just poking around at it. I mean, that's 80% of my time on this project was just getting the photos into a way that I could load them on to run them on Paperspace. And if there's nothing else,
All right. Thanks, RK. We did the turtles, ice skates. So this section I thought I changed a little different, because last time we just kind of reviewed what Jeremy's lecture was. So this time I thought what we would do is we take his notebook that he did in the video, the MNIST one, and like he said, just walk through all the code cells and just see if we can't explain all the way till, I think he got to, and then, so let's see if we can do that. Can everyone see my screen? Am I on the?
I still see the slide.
Will you still see? Let me. Have to. How's that?
Yep, see it now.
Okay.
So do you guys want to run with the clean one where there's no stuff and?
I would prefer to cheat.
Cheat? Okay, so. And okay, and this is what we get when you, what happened? Is it not loading?
It's spinning up there at the top.
Yeah, it was. And this is Paperspace.
Yeah, I'm not super happy with Paperspace. I've been using it and it works, but it does take me about 15 minutes to get to my notebook active.
Yeah. Okay, so should I just run these cells or we'll just talk it through? I'll run them. So I guess this part's pretty easy, right? You know, when he's pulling out the MNIST sample, he's going to pull out 3s and 7s. I think, well, for me, that was easy. Everybody else was okay? Yes?
Yeah, that makes sense.
I take silence as a yes. I think when he started, I'll show you where I started slowing down a little bit. I think
I mentioned if you hit Shift Enter, it'll run it and go to the next cell. Like
yeah, I know. I just didn't want to.
Hey guys, have you linked your files to a GitHub repository or a local repo? Because if you link in via the Fastbook, it disappears every time any changes you make, right?
Yeah, I pull the repo.
Okay. Oh, okay. Okay, understood. Yeah, thank you.
My Paperspace. I just
sure. Thank you.
Then he's doing an array, right? And instead of an array, he's using a tensor. I'm really new, so I didn't actually know what a tensor was, so I had to spend time reading that, watching videos on that. So then he does this. Right? Did anyone do the 7?
Yeah, I changed the colors for fun from grays to blues and reds, and did not do any matrix slicing, and so it was fun to see different full digit.
Yeah, I did too. I didn't change the color, but I just tried to see if I could pull the 7 as well with the full number. So I guess I understand what he's doing here, except, you know, when he's trying to do the ideal 3 and 7, this is the part I'm understanding what he's doing, but I don't think I can do this myself, you know, the way he's thinking. So I don't know if anyone got that.
Wait, let me ask you a question. I mean, since you said you can understand, you've done coding in other languages, right? And that could be the reason that is biasing the way he's using list comprehensions. Am I correct in making that assumption?
Yeah.
Okay, sure. Look, I found it very hard when I started with Python to, I mean, I've used C++, C, Pascal, Java and all. So, but this list comprehensions, squishing the entire for loop in that one structure and mixing the sequence of operations within that one line as to what happens after the other is confusing. Is that what your question is about? That I think I can attempt to explain.
Explain.
Okay, thank you. So So think of it as a normal for loop. When you say for O in sevens, right? Let's take the first line. For O is a variable which internally within Python, they're separating. You don't have to separately define it, or so many languages have started doing that now, right? So if you read that part first, it says for all the objects, correct, that are in sevens, which was defined in the previous box, right? What you do is you open the image, the first operation inside the outer set of parentheses, the curly ones, the circular ones, not the square ones, right? So you open the image, right? So it opens every image one by one, right? And then it creates a tensor out of them, right? So now the tensor is created, open an image, create a tensor, open an image. So all these sevens are handled like that. And then the net result is a single tensor. So that single tensor, and the trick here is what he explained somewhere either prior to or later on in this description chapter, in the chapter is, if you think of tensors, and now I'm going beyond answering the question just for a second, if you understand the shape, the rank, and the axes, there are three things he says, I do not remember which ones exactly, and construct it mentally for 2 or 3 dimensions, then you'll be able to easily replicate whatever we've done in matrices or in other places with what he's doing now.
But how would I know how to use this list comprehension unless he showed me here?
Sure. So I made 2 rules for myself. One is wherever I'm using a for loop, right? I'd rather use an inbuilt construction in the language because the computational expensiveness, the O notation, etc. wise, this will be better, right? That's kind of a generic rule I made for myself. That's inefficiency of Python or language or programming, whatever, right? So that is one. Second is whenever we see a set, and this is where, again, Python is very strong in inbuilt data structures, which we've all learned, but but in other language, you have to treat them. And what are those structures? When you look at lists, sets, not queues, but there are a few other, I forget, right? Ordered sets and all, right?
Dictionary.
Yeah, you're right. You're absolutely right. Dictionary. And there's one more I forget, right? So whenever you have such a collection, and collection is a general term, which also comes from Java, right? So whenever you have such a collection of objects, right, which you can visualize as being together, you start thinking of, do I have to process them en masse together, or do I have to process them one by one sequentially? Aha, sequential. So that would tend to be 3 loopy stuff that we do in other languages, like while loop, for loop, and a do loop, right? With different beginning and end. The most equivalent way, again here, this should be something in list comprehensions. I think these 2 sequences, if I can wrap my head around that when I'm starting to code, then I can force myself until it becomes an intuition after maybe some while it will, right? To start to use such a structure. Alternatively, right, what you would do is you write a simple pseudocode like for loop, quickly type it in a markdown or otherwise, right? And then say, how can I cut it further, use a cheat sheet. I think, I hope that helped.
I think that's a good description of what it is. When I think of them, I use list comprehensions pretty much every day. And I think of them as almost inverted for loops. So the for, and if you had a conditional, so the if part would come after the for part. And he doesn't get into that here, but that's a whole nother, like once they get too long. So if you have a conditional where you have if, else, like go back to a for loop because it's too hard to read. But in this situation, this is a perfect example of where you use list comprehensions instead of a for loop. So what I would say is, Andy, take this line and try to just convert it into a for loop and see if you get the same answer. And as soon as you do that, you'll realize how it works.
Yeah, and then as you're describing it, RK, something else struck me. When we were doing loop structures, remember there were like 3 things that constitute a loop. begin criteria, or like something to be done in the beginning before the loop starts, between different types of loops, the end condition or the exit condition, and the body, right? And the looping mechanism, I think, and I repeated one, but those are three things. Those three things are all embedded in one structure here, one statement here.
And the conditionals, just to add, you get the conditionals to go. It's a very powerful structure.
Yeah.
And it's a list processor, but it returns a list.
Yeah.
Don't forget that. That if that's not a tensor, that's an array of tensors, is it?
It's a list of tensors.
Okay, good. Which is the stack he's talking about.
Would you say that like whenever you have a short for loop, you should consider maybe using a list comprehension instead?
Yes,
as a way to be like, when should I use this?
Yeah, I think that's a good rule, because if it's very complex, I would get confused in constructing the syntax of that statement and perhaps do it faster in a for loop.
Yeah,
I think my perspective is sort of if you're just prototyping something, if you're trying to get it to work, if you're learning deep learning and not Python, and you have for loops at your disposal, probably I wouldn't think it's a super great use of time to figure out how to transform my for loops into list comprehensions, just as a different perspective.
I agree in some respects, Daniel, but I think once you see how it inverts, and I'll post a video that I watched a while back where a guy goes through and like really, he takes for loops like you'd normally write and converts them to list comprehensions. And as you see these examples unfold, it just becomes really obvious when you should and when you shouldn't use it.
Okay, great. We got the image. No. Is it still running? Oh, it's finished. Yeah. Maybe it's just slow.
So in that case, do they averaged every pixel position throughout all the stack?
Mm-hmm.
Is that okay?
Mm-hmm.
No distance or anything, just straight right through the stack. The average value is boom. Look
Absolutely. So if there are 6,000 odd images stacked, so it just goes down every 6,000 of those pins or lines and writes the average down. Absolutely. Into 20, and there are 28 by 28 pixels, right, in each. Or 128 by 128.
And those are handwritten. Look how perfect that 3 is from thousands of handwritten 3s.
Yeah.
That's pretty cool. Pretty interesting.
So I would pause right there. Like where he says L1 norm, L2 norm, I can describe that if you're like what that guy is doing there. If you
do it, we need the reinforcement.
Sure, I'll make it short. That means you already know that, right? So this is very funny, right? And when you pick up one of these regularization books, and I said like I've done a fair bit in scikit-learn, and they use such complicated mathematical descriptions and what is L1 norm and L2 norm, and there are different names for it and how to use it for when for overfitting resolution and otherwise, and addressing bias and variance. But it's very simple, right? You know, we've all taken 2 points and found the distance between them, you know, and we know the formula underscore, the under root of y1 minus y to the whole square, x1 minus x to the whole square, blah, 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 right? That's exactly what these guys are doing, right? So if you have 2 points, just take them instead of multiple coordinates, just 2 numbers, and you subtract them, it's called L1 norm. It's the absolute difference. And the reason for absoluteness is explained very well. So, I mean, I love the way he's described them here. These two terms are used a lot. So I hope that was helpful.
Any other comment? Okay. So here's where I start to have to slow down. I understand what he's doing here. I'm getting a little when he's doing this. And then he's getting the same numbers he's saying as he got up here. So I guess these are the functions that are doing this.
Try using the doc command on it. Put it in a new line and use doc of f.l1 underscore loss.
He just said they're built into PyTorch, yet they're nothing more than those simple formulas.
Yeah. Try that if something comes up. Well, we'll have to figure out what the exact structure is. But yeah, I think Dave.
I think you got to include the f. The f dot.
F dot maybe, or f with a functional parentheses too. It's a function.
What was that, Cliff?
I think put f dot in front of L1 loss.
You put an @ sign?
F
no,
right there.
F dot.
F.
It's got to be like exactly as it is in the.
Oh.
It might have to be capitalized.
It's going to look it up, and you might need a function. There you go.
There you go. So whatever he described in his sentence earlier, the L1 norm thingy, that's exactly what he's writing it down here as a complicated function, right?
So he's doing this for you. Is that what it is? And then later on, you'll use these.
Sure. So there's a slight difference. If you look at the text above, he talks about L1 norm and L2 norm, right? The L2 norm is actually RMSE, root mean square error. And here he's just talking MSE loss. And there are different so principally, when you take a square root, if you take a square root of a number that is less than 1 or more than 1, the compensation is very different, right? If you take a square root of 2, it will be 1 point something. If you take a square root of 0.02 or 0.2, it will be different. So both of these things have a different effect. In this case, for our purpose, he's simply saying, hey, by the way, there are these ready-made functions, use them. And for us, as long as we plot those functions as we run through different epochs, that's good enough, right? So these are just values he's using. And within the values, if you look at the values he's returning, 0.30250 something and what all, that is, he's simply comparing it against. So here he's doing A3 against mean of 7, right? And so he's saying A3 is definitely will have a very high loss value when it is compared against mean of 7 and not mean of 3. And that's all he's saying.
Okay. And I think this section, he's just showing you like the NumPy and tensors, right?
Similarities.
Yeah. And then to get used to using this. And then this is the broadcasting part.
I didn't quite understand this one. Like, this was difficult.
So can someone explain it to me?
Yeah.
If you'll want me to, but go ahead, someone else can speak.
As I understand it, and I remember taking the class from Andrew Ng. When you multiply arrays that are of different sizes, it can act like it's the same size when needed. So if you have a scalar multiplied by an array, well, that's a bad example. It's hard to explain, actually.
Let me
go ahead.
I'm going to explain that, and at the same time, I'm going to put a link in chat because I have to refer to TensorFlow, and it's very simply explained there. And I'll cheat and give the same explanation from memory. But hold on, let me paste there. So this, if you see, so basically what happens is when we do matrix operations, right? Let's say you have a 2 by 2 matrix, or let's say a 3 by 3 matrix, and you have a scalar value, which is just a single number, right? And now you want to multiply the two, right? So let's say 3 multiplied by a matrix that is 3 by 3, just like 3 rows and 3 columns of numbers, right? And so there are different kinds of operations you can do. You can do element-wise operations, and you can do matrix-to-matrix multiplication, what we typically know as dot product and cross product, right? Now, what broadcasting does is, sorry, before broadcasting, typically what happens is when the sizes of the matrices are different, the language will complain, right? But in this case, what he's saying is that the language, the broadcasting with all of these conditions, and I don't know the exact conditions, but what broadcast is doing is it will assume that the matrix that's of smaller size is as large as the bigger matrix, right? And do the operations correctly.
Yeah. It'll add the dimensions as necessary to make it work.
It'll add the dimensions as necessary, right? And I have so many questions behind that, because I'm like, that's like a random thing, right? And in math, everything has to be precise. So I cannot explain it any further, guys. But that link I posted, if you look at how he's taking A equal to this matrix, B equal to this, then he adds them. The simple explanation I gave stands.
Yeah. Well, how is it used in the lesson? That's maybe a good example.
Well, I think in the lesson, he's probably just going to use it because he has a stack of like 1,000 images for each, like for 3s and 7s.
Right.
And I think he's just going to use it to
subtract
compare
the mean.
them to the ideal 3 and 7, which is only one image.
Mm-hmm.
So I think that's what he's going to use broadcasting for.
Right. Where is that? Right. Is that
basically duplicate the one image 1,000 times.
Yep. Right there. I think that's right. Well, no. Yeah, the distance between the valid 3 tens and the mean 3, right there. Yeah. That's valid 3 tens is a huge matrix. Mean 3 is of one image, and it calculates the distance properly because it runs the calculation as if it had a stack of mean 3s.
Right.
And he uses this to make like a Boolean like function, yes, no. Right.
Even more powerful. That's not there. That's above it. That's not what's being shown not right there, but above it is. Well, that's where it's comparing. The answer you get back comparing what you think is a 3 to the mean 3 should be very close, right? Or it should be very high. Comparing what you think is a 3 to a 7 will come out very low. So you just compare the two.
Well, I think it's the other way around.
Oh, maybe I forget
because it's a distance, so you want the distance to be low if it's a 3.
Yes, they should be more similar, which would be a lower distance. Yes. Good point. Yep. Low error. 0 error would be a perfect 3 compared to the perfect 3. And then converting the true to a tensor or to a float. Oh, yeah.
This is some fancy footwork here.
Yeah. I think I'm going to have to watch this several times. So this is, I think this is where he stops, right, in the video. He starts to go a little bit with this, but.
How far? Yeah, he went through it.
I went through it.
Oh yeah.
I was really happy because it's been so long since calculus, and I understood what he said, so I don't have to retake it.
Nice.
Yeah, I think he stops here.
No. He goes further.
Yeah, he goes further than that. He goes through all the step size stuff.
Yeah, this is like the core SGD talk, right?
Yeah.
This whole iteration down that curve. It's that was pretty good too. Very, very instructive. Very instructive. That's where he stopped.
He starts to go a little bit on this, but he kind of stops right there. So if you're in the book or chapter, he stops like right here.
Correct.
So I think the more important thing is like what Anya said in the Slack is that it's okay to go through some of the, the book and binder and stuff, but if you don't get L1, L2 norm, broadcasting, and STD, I think you should concentrate on that.
That's
my opinion.
Yeah, I have to agree. The stuff I've taken away from previous exercises has been just a really good feel for gradient descent and a lot of the matrix stuff, a lot of the tensor stuff, because it becomes like magical pretty soon, but at least you know that it isn't magic. It actually has real functions.
So if someone were to advise you, and like you said, if you only have limited hours, like let's say you have 5 hours per week, I think you should get the SGD and broadcasting and L1, L2 norm as the one out of this lesson. And then list comprehensions are great, dictionaries are great, yeah. But I think if you don't get the SGD, I think it'll be harder as you keep going.
I'd agree with that.
Yeah, just walking through the notebook actually is very useful, like you just did. Changing something here and there and make it trigger an error and say, oh, why did that make an error? Oh, I see why, because I had to have the array looking this way.
Yeah, I'm not confident enough though to like maybe take a set of 4s and 6s and do this same thing.
That's a good exercise right there.
Yeah.
Good idea.
That's that where you just take the real problem and move it over just a little bit using the same techniques, but 4s and 6s. That would be, the 4 would be interesting because of the way the different open and closed and all that.
People always mistake my 9s for 4s.
Me too.
But again, you don't want to do that unless you're pretty confident on, because that's going to take you a while. And I'd rather like get to the next lesson and learn the meat of the next lesson.
Right. Yep.
With limited that. Now, if I didn't have a job or anything, I'd all my time just do this. I would do every number. But being that time is of the essence, I think I just need to get the main meat and keep moving on. Otherwise, I'm going to be stuck in lesson 3.
Yeah, I kind of got twisted off doing the binder and the dog. I'm going to stay focused on the material.
Did anybody do a blog?
One good way to to gauge one good way to like evaluate if you're ready for the next chapter is go to the questionnaires and try to answer them off the top of your head. The questionnaires are the fantastic resource. Everybody's finding out that it's a good way to evaluate whether you understood the material or not. So if you can answer them pretty much at the top of your head, I think, yeah, definitely that's a signal to go to the next chapter. Yeah, you don't have to spend that much time anymore on that if you can answer the questionnaire answers, especially the why ones. Yeah, so if you don't have time to answer each and every question, just pick a why and then try to answer that.
And I think to your point, Butch, is like Jeremy even, he hasn't really done a lot of that explanation in this one, but in the 2019 version, he would tell people, just watch all the videos. Don't do any of the work. And then when you get done with the last video, go back and do all the work and rewatch the videos. And he has a very iterative approach to teaching. And so like once you feel like you're pretty comfortable, go to the next thing, because you're going to learn something that's going to shed light on what you just tried to learn.
I'll just give a little hint here. The questionnaire, I think, is going back on the chapter 4. If you look at, I think the playlist thing, they have questionnaires that are per the video. So if you want to do that one.
There's also a questionnaire on the video, which is like more matched with what the contents of the video are. So it chops off like some of the questions here in the chapter. So go to course.fast.ai. No, course.fast.ai. Yeah, that one. If you go to the lessons, there's a questionnaire for each one. It's not showing up.
Well, on yours, it would show up there.
Yeah, it should show up.
There's a list of questions. That's what
they're at the bottom of the notebooks, though, right?
Yeah, for each chapter. But like as you, it doesn't. Like he starts in one chapter and doesn't necessarily finish one chapter for each lecture. So there's definite overlap. If you don't read by chapter, if you watch by video, it might cut off at a different point. But the video questions, and I'm not sure why Andy's screen doesn't show the what do you call this, the questions
under notes. I see them.
Yeah, so they're more or less like in sync with each lesson. Yeah, so there's a questionnaire for each chapter.
Right. So yeah, in the current chapter 3, the last question is just about gradient. It doesn't even go into the next thing.
Yep, exactly.
Okay. Very good.
So if you wanted to use the questions, is what I was saying, use the ones that are in the video little playlist. Do we have any other questions? Is anyone having an issue?
I have a setup question, guys. So I spent a lot of time putting WSL2 in place, the Windows system for Linux. And then I had TensorFlow was not running, so I downloaded and imported that. And I've not yet used Conda to put Fast.ai in. So I need some advice, suggestion, what will best kind of experience thing. Should I just use, duplicate the Fast.ai repository on my GitHub, or should I download it And how do I know what I worked on a notebook? The problem I'm trying to solve is how do I know what I worked on a notebook and modified it because I typed my notes and that's how I'll remember, a week from now or anytime after that, right? So how are people doing that?
Do you intend to do it locally though? Like you're going to run the notebooks, the learning note locally?
I care about storing my modifications in the notebook in a repo, and that is mine, or like that I can use. It's like a book to me, and I open a book and read my handwritten notes, or now my electronic notes. It floods my memory with everything how I remembered it, right? How I learned it. That's what I want to do.
I see. But I mean, when you say you did WSL2, are you going to run the learning locally? Is that your intention?
That was my intention. So first session I was playing with AWS. Then that didn't work. Now I did paper gradient and learned from as people were doing it. I said, oh, this seems great. But that didn't vaporizes, right? I mean, every time it's a new notebook, the notes I did and new cells I created are lost, right? So my thought is to store them.
So WSL2 only does GPU in the developer in the fast string of the beta. So you'll have trouble in WSL2 running anything that's GPU related. Just to start out there. So unless you want to install the fast string on your whole machine and be
no,
I would not recommend that.
No, as Dave was saying, I just want to learn this, not learn this setup. It wastes too much time. So I guess you're saying that just and I don't want. It seems so. Then GitHub is the next option, right? So between forking and duplicating the entire repo, I'm thinking duplicating will be a better idea. So I don't accidentally push any newer changes.
Can you use Colab?
Huh?
Like Colab might be the easiest way to do it.
But Colab, so is the storage permanent? Would it not go away? Or will I not have to pay for it?
I spend 30 cents an hour and just use Google Cloud Platform. They have a notebooks server that's so darn easy. That's with GPU.
And where do you store your notebooks, your code?
I'll clone the repo. That is the one that I loaded in to my Google Cloud Platform environment.
Okay, and you pay for that storage then because it's not GitHub or GitLab.
Yep.
Okay, understood.
That's just one option, sure.
Okay, yeah, sure. Thank you. You answered my questions. Thank you, guys.
Well, just a suggestion, if you're using Colab, and this is not necessarily for pull-in, you can save your notebooks as part of your Google Drive. So the data isn't stored. So if you don't care about the data, like if you're just downloading the data from like the URLs, pets or mnest or whatever, and you don't care to store them anyway, you're not using your own data set, Colab is fine. And then it's just like a document. So it's in your Google Drive. You can like move it around, update it. You can create a copy of it. I use it all the time to like create my own notebooks. And then, but yeah, as you said, the data goes away. So like if you have a model that you want to save, you can link your Google Drive with the, when you're running stuff, you can like link them and then just make sure you save it before you end the session because it goes away. But other than that, just the notebooks themselves, if you're like taking notes and putting them, I think Colab's great because when you save it, it puts it automatically into your Google Drive. So you don't have to like push it to GitHub. Although I do that sometimes just to make it easier to share to people. Like I have it in a GitHub gist or a GitHub notebook, in a GitHub repo. Okay. So definitely Colab is an alternative, especially for notes.
Okay.
Because like it's like a Google Doc. You can share it to people, and they can interactively work on it. And that's not something you can do with Jupyter.
Okay.
The note. So it's like Google Docs. So yeah, that's an option as well. I think.
Okay. Okay.
I don't know if you would want to have the pro version. I would just stay with the free version.
Yeah. I don't use the pro version. I mean, it isn't much. It's $10 a month, I think, for the Colab Pro. But again, the advantage I think is you can use different runtimes, but I'm fine with, for the course, just the free one is fine.
Okay.
$10 a month on Colab, is that with a GPU?
No, it's a Colab. The Colab Pro is the one where you can like have more powerful GPUs or and bigger spaces and that kind of stuff. But it's, I mean, for the purposes of the course, you can use the free tier pretty well, and that's what I've been using actually.
I have no problem with $10 a month.
Yeah,
I mean,
yeah.
come on.
But, what I'm saying is, you don't get much more. I mean, it's okay to use the a free version for the course. I guess if you're doing more of your personal stuff and you want more powerful machines, then yeah, the $10 might make some sense.
No, thank you guys. I think that answers the immediate. I think what you also added regarding Colab or any other cloud and GPUs, my thought is to first get this pat sort of right, and then decide between AWS and GCP, which one do I want to specifically run these. I'm quite familiar with AWS, but I think for me that decision will come later. But I think I answered my question for now. Thank you.
Any other questions?
Has anyone used the ONXX? I'm trying to use Lambda, like AWS Lambda, and I think I might have to use ONXX. So has anyone done it? Did I get asked questions?
Well, we'll be asking you.
No. I know somebody. There's this guy who was like our guru, the expert during their classes when we were taking it last March. And he was saying he was advising somebody, a high school team on doing this stuff. And they used ONNX to like move it to a mobile phone. And he basically was amazed that these kids were like being able to do it because it looked like it was so complicated. So yeah, it can be a sinkhole, a time sinkhole to make your model run on mobile. So you can convert it to ONNX, and that's part of the process. But he was saying it's just so tedious and complicated. So I don't know if you want to spend your time, unless you have lots of time to go down that sinkhole, rabbit hole. And
yeah,
I'm pretty sure you'll learn stuff, but yeah, I'm not sure.
Interesting. It's JavaScript. Like I run with it a little. But
yeah, so I'm not used ONNX, but I did create a model using TensorFlow, and this was all using abstract and not going into the details of, or not actually coding and programming. Not actually building the model. So TensorFlow, what it does is there's a TensorFlow JavaScript and there's a TensorFlow sort of different models. So if you build a model, you can very easily convert it into Size or TensorFlow for JavaScript, which is very portable. And I'm forgetting one of the conversion formats to a phone. So I was actually able to run an app successfully using on an Android phone, right? So to me, when I read the word ONNX in the book or in the material, I of course didn't have time, but I thought it should be something equal. I mean, I'd say if you can find a web page or something that compares the two, unless you have a compelling reason to use ONNX, you should look at these formats too.
I know with my project, the developer who's on the handling the front end and the web app is using C# and JavaScript. And so for me to supply him a model, it has to be ONNX. So I've spent about 45 minutes or an hour reading about it, but I'm definitely not capable of telling you how to do it. But if you find good information, please share it.
Yeah, I will.
I will also, and I can, and I'll do some homework I can't recall. I also used Apache ML Flow at the beginning of this year so it basically, it's a model lifecycle management open source coming out of Databricks and all. They are incubating it. And it's a very effective way to store all the parameters, the data sets, the versions, the performances, and everything that comes out of a single run of a model, forget even an epoch, right? So I coded how to manage the performance and all. And there it was model format neutral, right? And I'll have to dig up some my notes and I can send that to you if you're interested. It does same thing other than portability. It's the management aspect.
If you listen to the Trimble AI talks, they've been hitting on a lot of those model management types of frameworks. That's way past anything that I understand.
No, Dave, I'll say something. I thought that model management, and actually I built a framework for model management, and I also built a framework for how to measure the performance of models and the learning curves and everything. It was amazing how I could do that without this in-depth knowledge, for example, of how we are doing with neural networks. And you can abstract them out, right? So it's not hard.
Oh, cool.
I'll be happy to walk you through if you have any questions there.
Do you think that's probably one of the easier frameworks, the ML Flow? I hear it talked about a lot. It's open source.
It is a very easy framework. I mean, it is super easy.
Okay.
It's just a bunch of for loops in an object called a model in some format, and everything that comes out stored in a very rudimentary database. There are startups coming up with kind of trying to make money out of how it is stored and kind of scaled.
Right. Optimize.
But it's very easy, yeah. I mean, it's not difficult at all.
Okay.
Yeah. Performance is tricky at measuring it, but.
All right, guys. Well, we're at 3 minutes. I just want to make a shout out to Sophia. I guess Sophia and Anya. I'm not sure if we have any other women on here that doesn't have video, but thank you for joining. There's a reason why we're kind of sharing and collaborating here. And I'd invite you to also go check out the YouTube video. You know, there's going to be a time, I don't know when the AI winter will unfreeze and there'll be lots of demand again for people like us. And whether you're good or not, they'll need you and they'll be looking for us. And I don't think they'll be looking at blogs and stuff. They'll be interested in seeing where are the videos, where are the projects. But I think if you're in a group like this, we're all helping each other, you're all participating, it makes it a little easier to not only find other career opportunities, but in the future, you're gonna probably have to do deep learning version 10, right? And you're gonna have to do this all over again, right? So I'd encourage you to continue to participate and keep coming week after week and make that effort, right? Those 5 hours count, right, Dave?
Yep.
So do we have any last comments there? Thank you again.